most important thing to focus on when they're asking you to go from general to standard form is completing the square. That's what's going to get you there. So you might want to go back in your book and review completing the square if you're having any difficulty with this, but for now I'll walk you through it. Now this is number 5 on page 296, and I've had a student ask me to help with figuring out how to go from this general form, the ax squared plus bx plus the number, into standard form, which looks like that. And remember that when we have it in standard form, we can basically do the graph from that because we have our vertex point, we know whether it opens up or down, and we know how much to multiply the y value by. So that's why it's valuable to put it in that form, and this doesn't tell us much except that the y-intercept is 1. It's not a lot to go on. So what we're going to do is have a look at this and see what we can do with it in terms of completing the square. Now, the +1 part we don't care about. What we're focusing on is this part here. And what we want to do with that is to write it in terms of what we would have to include to make it a perfect square when we factor it. So when we factor it, if it's a perfect square, when we're foiling it, whatever number is being multiplied is going to have to add to 6 when it adds itself. So that means to find this middle number, we would divide by 2, and in that case, this is 3. So that means when we set up our perfect square, it's going to look like that. The 3 goes here. To find out what goes here, because we're going to have to adjust our formula, we can't just randomly change it, is we have to square this and then add that value here. Now the problem with that is we just added a value to an equation. We can't just do that. We have to do the opposite to cancel it out. Otherwise, I'm just making it a brand new equation. It doesn't equal what it used to equal. So I'm going to subtract the 9 outside the set of brackets. But there's still this +1 outside the brackets that I have to deal with as well. So now this whole mess has become x plus 3 squared, because if I factored x squared plus 6x plus 9, I would end up with x plus 3 times x plus 3. Check it out. See if you can go through the steps and make sure that I'm not messing with you. And then the rest of this is just -9 plus 1. So -9, +1 gives me -8. So here I have, we can just add the y equals here. Here I have standard form of the same equation. Now, in your book it says prove it algebraically. Well, we just did. The way that I would suggest that you check your answers is to put these into your graphing calculator. So when you hit the y equals button, write it in like this, and then just page down, or just slide down to the y2, which is right under the y, and put this one in. I'll show you what I mean. I'm just going to grab my graphing calculator here, and if we turn it on, hit the y equals button. Alright, I've got my graphing calculator. I've got it on the y equals screen, and the first one I'm going to put in is x squared plus 6x plus 1. And I'm not even going to bother to graph it. I'm just going to put it down 1 to the y equals, so I just page down. And now I've got y2 equals. And now I'm going to put in this other formula, bracket x plus 3, close bracket, square it, and subtract 8. So now I've got that same equation as right here, and if I graph it, I'm watching this here, this is showing me that it's finished working. There's no other line. The reason is they've both overlapped because they are exactly the same line. So if you want to check your answers, just put it into your y equals, put the first one, the general equation, in, put the one that you've made the standard equation in, and when you hit graph, it should only give you one graph. just be aware when it's doing its little thinking thing, it's showing a little blinky blink here. So as long as the blinky blink is over, then that's it, you're done. And as long as you still have one line, then you're right. Yay, you win.